All right. Hi, everybody. We're looking through the trigonometry review for calculus. Okay, last question here says a right circular cone is to be inscribed in a sphere of radius 5 centimeters. Find the maximum volume of the cone. Okay, so here we go. Here's our sphere, and then we're going to put this cone in it. Okay. Now, remember the volume of a cone is 1/3 pi r squared h. Okay, volume of the cone 1/3 pi r squared h. So now what I got to do here is I'm going to pull out some trigonometry here to make this question a little bit easier to solve. Now, from the center, I'm going to go out to here and to the top here because I know that those are 5. Those are each going to be 5 because the radius of the sphere is 5. Now I'm going to focus on a triangle that gets formed if you follow that radius down to the circle at the base of the cone and then out to that point on the side of the sphere here. Now let's just call this x and we'll call this y. The angle that we're going to use will be this angle right there. Okay? Now, what I know is that y, okay, or I should say it like this, the sine of theta is going to equal y over 5, meaning that y will equal 5 times the sine of theta. Okay. The cosine of theta is going to equal x over 5, meaning that x is going to equal 5 times the cosine of theta. Okay, so now I have expressions in terms of theta for x and y. Now what I'm going to do here is I'm going to work on this formula for the volume of the cone. Pi times, well, okay, r. The radius of the cone is going to be x. And so I know that x is going to be 5 cosine of theta. So this is going to end up being 5 cosine of theta squared. And I know that the height of the cone, okay, the height of the cone is going to be a little different. That is going to be the expression 5 plus y, okay? So the height of the cone is this line from here to here. That's 5 plus y. And I know that y is 5 sine theta. So this will be 5 plus 5 sine theta. Okay, so now let's just kind of evaluate what we can. This will become 25 cosine squared of, and I'm going to take out the 5 out of that, make that 1 plus the sine of theta. Okay, that's quite the expression there. Let's just piece stuff together. So this is going to end up being 125 thirds pi. And now I'm going to get cos squared theta 1 plus sine theta. Okay, now I'm going to end up taking the derivative of this in just a moment here, but I'm thinking that this would be easier to work with if this was all in terms of just sine, okay? And so this would become 125 pi over 3. Well, this is going to end up 1 minus the sine squared of theta times 1 plus the sine of theta. And so that is 125 pi over 3 times, now I'm going to expand this out here, and I'm going to get 1 minus the sine of theta minus the sine squared of theta minus the sine, sorry, I don't know why I did that, 1 plus the sine of theta. Sorry, I don't know why I put that negative there. And then this will end up being sine cubed of theta. Okay, well, a whole lot going on there. And maybe that was the smartest idea. Maybe it wasn't. But anyway, let's keep carry on here. If I now take the derivative of this, I'm going to get 125 pi over 3 times, whoops, okay, this will be, the derivative of 1 is 0. This will be the cosine of theta, okay, minus 2 sine theta cosine of theta, minus 3 sine squared of theta cosine of theta. Wow, lot going on there. Oy, oy, oy. Well, I tell you what, let's factor out that negative cosine there. Okay, and if I do that, I'm going to get negative 125 pi over 3. Ouch. Cosine of theta. And then if I take out the negative, this is going to be 3 sine squared of theta plus 2 sine theta minus 1. Okay? Now, cosine of theta, either cosine of theta can go to 0, or this expression right here is going to go to 0. Now, cosine of theta goes to 0 at 90 degrees. Okay, the smallest angle that goes to 0 at is 90 degrees, or pi over 2. Well, that ain't going to happen. So that particular root is no good. So to say that the cosine of theta equals 0, so if theta is equal to pi over 2, no, that doesn't make any sense. There's no way that that can work practically in this problem. So now we got to look at solving this quadratic here. Because remember, I'm sorry, I should have said before, we're setting this equal to 0, and we're solving where the derivative goes to 0 here. And so I'm just going to look at where the factors are going to make that 0. So now I got to look at 3 sine squared theta plus 2 sine theta minus 1 equals 0. Well, I don't even know. I don't even know if that is going to have a root here. So I'm going to check the discriminant. So b squared minus 4ac is equal to, well, that's going to be 2 squared minus 4 times 3 times negative 1. So it's going to be 4 plus 12. Well, that's 16. Now what that tells me is not only will this thing have roots, but because the discriminant is a perfect square, I know that that also should be factorable. So I should be able to take a look at that and say, okay, well, this is going to be 1 and 1. This is likely going to be the sine of theta. This will be the sine of theta. And then to get a positive 2 in the middle, this will have to be plus 1, this will have to be minus 1. So either the sine of theta is equal to positive 1/3, or the sine of theta is equal to negative 1. Now, if sine of theta is equal to negative 1, that means theta 3 pi over 2. And that doesn't make any sense in this context. There's no way that this is a reflex angle. Okay? So now we're left with sine of theta equal to 1/3, which again can happen in the first and second quadrants. Okay? So that could be the first quadrant. It could be a second quadrant angle. I already know I'm going to reject the second quadrant angle. I'm going to find it anyway because I feel obliged to, but we're not going to use that. But what we're going to do here, sorry, I'm just going to make sure that I'm in the right mode here. And I'm not in the right mode. That is so odd. Sorry, I just got to change. I didn't realize my calculator here was in the wrong mode. And so now I will come through here and I'm going to take the inverse sine, okay, the inverse sine of 1/3, because I don't know what that is off the top of my head. Wish I did, but I don't. And so now, sorry, I'm just going to double check this. That didn't actually work here. Okay. Well, okay. I'm going to take my answer here. This was a little weird. I'm working with an Inspire here, and I thought I changed it to radians. I obviously didn't. So what I'm going to do here is I am going to multiply by pi, divide by 180 to convert that into radians, and I get this. Oh, it did it twice to me. Ugh. Okay. Anyway, this turns out in degrees to end up be 19 degrees. So this will be 19 degrees in this quadrant, and then it'll end up being. I'm going to do this again. Yeah. Whatever. In the second quadrant, that's going to end up being, what is it, 180 minus 19, 161 degrees, which again, that doesn't make any sense here. So I'm left with this 19 degrees. Okay, so now what we're going to do here is we're going to go up and we're going to evaluate for the maximum area. So, and I'm going to go basically, well, I might as well even go right up to here. I'm going to be kind of lazy. I'm going to go to, sorry, not to that point, to this point right here. And the reason I would go here is I worked it out that the sine of theta is equal to 1/3. So now I'm just going to plug in 1/3 in for sine here. So this is going to end up being, in brackets here, 125, what is that, times pi, divide by 3. And we're going to multiply this by 1 plus 1 divided by 3 plus, sorry, minus, my mistake, minus Well, this is going to end up being 1/3 squared, so 1 divided by 9 minus 1/3 cubed is going to be 1 divided by 27. Close those brackets, press enter, and I'm going to get two different answers here. Well, not, sorry, I shouldn't say two different looking answers. My volume will be 4,000 pi over 81. Or if you want an approximate solution, this is approximately equal to 155.14, and our units here will be centimeters cubed. And so that's the volume that we're looking for.